This is going to be the beginning of part 2 of chapter 17. We're going to start with the stability of air, different types of clouds that can form, and then different types of precipitation and how to measure them. So types of stability. We could have stable air. This is air that resists vertical displacement. So it's cooler than surrounding air. So that means it wants to sink rather than rise. There's no adiabatic cooling. And there's something called absolute stability can occur when the environmental lapse rate is less than the wet adiabatic rate. And this is just a diagram describing absolute stability. Make sure you read the chapter to understand this fully. More about stable air. If you wanted to look at the weather in a certain region where there's stable air, it would often result in widespread clouds with little vertical thickness, so these would be thin clouds, and if there was any precipitation, it would be light to moderate. When air is unstable, all right, so when we have absolute instability, air acts like a hot air balloon and will rise. So when air rises, we know what happens. That's when we get clouds to form. So this is when the rising air is warmer than surrounding air, less dense, and it'll continue to rise until it reaches an altitude with the same temperature. And when this happens, we tend to have really large vertical clouds forming. So when we have absolute instability, we have adiabatic cooling. The lapse rate is greater than the dry adiabatic rate, and clouds are often towering when this happens. There is one type of instability called conditional instability, and this occurs when the atmosphere is stable for an unsaturated particle of air, but unstable for a saturated parcel. So this determines to a large degree the types of clouds that develop and the intensity of the precipitation. And this is just another example of, or this is another graphic showing you conditional instability. All right, so cloud formation. So we already talked about condensation. That's the process from going from a gas to a liquid. So this is when water vapor in the air will change to a liquid, and it sometimes will form dew, fogs, or fog or clouds. So we mentioned that water vapor requires a surface so that the condensation has to occur onto something. So this could be basically anything. It could be grass, a car window, etc. If we want to form clouds in the air, there has to be something in the air for the water vapor to condense on. And we call these things condensation nuclei, and they can be dust, smoke, or any other pollutants in the atmosphere. They could also be ocean salt crystals, which serve as hygroscopic nuclei, and hygroscopic just simply means water-seeking. So clouds are simply made up of millions and millions of very small water droplets, or sometimes they could be made out of tiny crystals of ice. Now we classify clouds based on their form. Now there's three basic forms. There's cirrus, these are high, white, and thin, cumulus, globular cloud masses often associated with fair weather, and then stratus. These are sheets or layers that cover much of the sky on an overcast day. We also classify them based on height. We have high clouds, which are above 6,000 meters. These would include cirrus, cirrostratus, and cirrocumulus. Middle clouds happening between 2,000 to 6,000. These would be altostratus and altocumulus, and then finally low clouds below 2,000 meters, stratus, stratocumulus, and nimbostratus. And nimbus means rainy. So these are the type of clouds that typically result in precipitation. All right, so clouds of vertical development, they form from low to high altitudes, and these are called cumulonimbus, and these often produce rain showers and thunderstorms. So this is just a nice graphic to show you the different types of clouds, so make sure you study this for the exam and quiz. Moving on to fog. This is considered an atmospheric hazard because it's a cloud with its base at or near the ground. So most fogs form because of either radiation cooling or movement of air over a cold surface. So there's different types of fog. We have advection fog. This is when warm, moist air moves over a cool surface. Radiation fog. This is when Earth's surface cools rapidly. So this forms during cool, clear, calm nights. And upslope fog. This is when humid air moves up a slope, typically in mountainous regions, where adiabatic cooling can occur. This is a picture of advection fog, so you have moist air that's cooled by moving over a large water source. Oh, I went wrong direction here. We have steam fog. Oh, sorry, I'm going back here. Again, different types of fog being evaporation fogs. We have steam fog. This is when cool air moves over warm water and moisture is added to the air, and water has a steaming appearance. And then frontal or precipitation fog, and this forms during frontal wedging, that process that lifts air when warm air is lifted over colder air. And rain evaporates to form a fog typically as well. So here's a picture of steam fog. Now precipitation when it rains, we're essentially talking about cloud droplets. So these are less than 20 micrometers or 0.02 millimeters in diameter, and they fall incredibly slow. And precipitation forms due to what's called the Bergeron process, where temperature in the cloud is below freezing, so ice crystals collect water vapor, and then large snowflakes form and fall to the ground or melt during the descent and then fall as rain. So actually most precipitation starts as either a solid piece of ice or a snowflake, and then only depending on the air that it passes through will it warm and form rain before it hits the ground. So these are just giving you relative size of condensation nuclei and precipitation sizes. And this is just a picture of the Bergeron process. Make sure you understand this process by reading the chapter. So formation of precipitation is something called the collision coalescence process, where you have warm clouds, you have large water-seeking condensation nuclei, where large droplets form, and then droplets collide with other droplets during their descent, and they form really large pieces of precipitation. And this is common in the tropics region of the planet. And again, a graphic showing you that collision coalescence process. More about precipitation, we have different types. We have rain and drizzle. Rain is droplets that have at least a size of 0.5 millimeter in diameter, and drizzle will be droplets less than 0.5 millimeters in diameter. Snow, of course, are just ice crystals that don't melt on their way down to the surface. Now we have sleet, which is a wintertime phenomenon, and this is actually small particles of ice. So these aren't crystals, these are big solid pieces of ice that fall and reach the ground. And this occurs when there's warmer air overlying cooler air. So rain will the precipitation will turn into rain and then refreeze as it falls. We have something called freezing rain, which falls as rain, but then as soon as it impacts the surface, it freezes immediately because the surface is below freezing. We have hail. So hail is different than sleet. Hail are hard, rounded pellets with concentric shells, and these range in diameter from 1 to 5 centimeters. And this is interesting how they form. So usually they occur in large cumulonimbus thunderstorm clouds with violent up and down drafts. So what happens is a precipitation droplet will fall, and then it'll freeze on its way down, and then an updraft in these cumulonimbus clouds will lift that frozen pellet up into the air, and this process just keeps repeating itself until you get a large round piece of hail that if you were to cut it in half, you would basically see what would look like tree rings. So it would tell you how many times it was uplifted into the air. And some of these things can get rather large. This is an extreme example on this slide showing you a 0.75 kilogram piece of hail, but it really does show you the layered structure inside, how this piece of precipitation has been continuously uplifted into the thunderstorm cloud over and over again until it finally falls to the ground. Another form of precipitation is called rime, and this forms on cold surfaces, and this is the freezing of fog, actually, or cloud droplets. Now, how do you measure precipitation? So measuring rain is fairly simple. It's the easiest form to measure. You can use your standard rain gauge, which uses a funnel to collect and conduct rain. Its cylindrical measuring tube measures rainfall in centimeters or inches typically. And snow has two measurements, its depth and also its water equivalent. So the general ratio is 10 snow units to every 1 water unit. So if we had 10 inches of snow, we would typically say that would be 1 inch of rain if it were to be a rainstorm. And this varies widely, but that's at least a good indication to figure out how much snow you're getting relative to if it was a rain precipitation. And that ends chapter 17.